This is a Redstone trainer demonstration conducted on 17 December 1959 at the Redstone Division, Department of Materiel, United States Army Artillery and Missile School, Fort Sill, Oklahoma. Sergeant First Class Gene R. Dollahide, seen here, was the NCO in charge of the school instructor personnel assembling the missile. The missile warhead resting on its transport trailer will now be mated to the missile aft unit containing the inertial guidance system. The aft unit is suspended by block and tackle rigging attached to the lightweight erector servicer A-frame. The two sections will be joined by the use of 8 non-destructive bolts to form the missile body. The completed missile body resting on the warhead trailer will now be mated to the missile thrust unit. The thrust unit is now suspended from the A-frame rigging. The two sections were aligned for mating with the use of 6 ball and socket guide pins. The two missile units were then secured together by threading 6 explosive bolts through the 6 guide pins. The completed missile is now supported by the warhead trailer and the A-frame block and tackle rigging. In the background, we see the Redstone School hangar. The rotating frame assembly, known as the tilt ring, is attached to the base of the thrust unit's 4 fins. The tilt ring will now be attached to its 2 pivot points on the missile launcher. The crew is attaching the external heating and cooling drop tank to the side of the instrument compartment. The drop tank maintained a constant temperature inside the instrument compartment prior to launch. The tank contained dry ice for cooling air and had electrical heater circuits to provide warm air. The tank was jettisoned just prior to rocket engine ignition. The missile is now being raised to its vertical firing position by the erector servicer lightweight H-frame and A-frame equipment. A 10-ton capacity winch located on the bed of the 2.5-ton erector servicer truck pulls a cable attached to the top of the A-frame. The rotating A-frame in turn pulls the missile to the vertical position with the use of 2 cables attached from the top of the A-frame to the sides of the missile. Note the carbon jet vanes used for steering at liftoff. Just prior to the missile rotating through its center of gravity position, 2 hydraulic piston snubbers engage the tilt ring, preventing the missile from tumbling over. Snubber hydraulic pressure is then slowly bled off, allowing the missile to settle to its full upright position. Next, 4 steering rudders will be attached to the 4 tail section fins. The rudders work in unison with the carbon jet vanes in the exhaust plume for steering during powered flight. The fueling ladder is now being positioned on the thrust unit. In this demonstration, the crew will simulate the loading of 25,000 pounds of liquid oxygen, or LOX, into the thrust unit oxidizer tank. Here, the crew is installing the LOX tank overflow standpipe. When the LOX tank is full, excess LOX will flow out the LOX tank vent valve and down the standpipe to the ground. The crew is now installing the LOX fill and drain valve to the LOX tank port. A short LOX hose is connected from the fueling ladder to the fill and drain valve. This is a LOX tanker trailer containing 18,000 pounds of LOX. Here a LOX hose is being hooked up to the LOX Y fitting used for 2 tankers. LOX will now be pumped from the tanker to the missile. The boiling point of liquid oxygen is minus 297 degrees Fahrenheit. This extreme low temperature causes a frost band to form around the exterior circumference of the LOX tank. During LOX loading, all LOX line fittings are constantly checked for tightness. Once the LOX tank is full, the tanker trailer pumps are turned off. All LOX hoses are then disconnected and drained onto the ground.